Today I will talk you a little bit more about the legacy type mapping functionality of MicroStream. The type mapping can help you when your data model evolves within your application. So you have a first version with a few fields in a certain class, and in a second version you have additional fields. You change your class, you rename your class, for instance, or you do even complex refactoring. Depending on that complexity, like only property changes, a class rename, or that larger refactorings, you need to use different types of solutions to handle those changes. If it's only a property that changes its names, most of the time it is completely automatically. MicroStream can handle that for you. In most cases, it's based on the Liebenstein word distance. If that does not give you the expected result, then you can do a manual mapping where you define the old names and the new names, and that is also the functionality that you need if you want to rename a class. Larger refactorings, they need more manual coding, low-level access to the binary storage, etc., and you need custom type handlers, which probably need some expert. I'll show you those three cases with an example and how you can use it, and there is also a GitHub repo that you can use to play around yourself. Our first version of the program has a data structure called lead, which contains the name of the person, the quality of the lead is the email, any note in the reference field. In the second version, we realized that we don't need a reference because most of the users fill it in the note anyway. So in the second version, we remove the data, we remove that reference property, and we also rename the name to contact name to make it a bit more clear, and we have changed the order. So if we have data from the old program, so let's run the old program that creates data for the first time or prints it out, then you see that you have some items with a reference and a name for a person. In the second version, although the lead is changed, we don't need to do anything because MicroStream generic type mapping handles that for us, that change, because it is a small change or a few properties that change. Most of the time it can handle it automatically. You just need to start the storage pointing to the same data, so the data is here in our channel. And when we print it out, then we will see that it can perfectly convert that old structure and use the new structure to work with our program. So we no longer have that reference, and all the data is still there in the new format. That's only done in memory. So it is, when loading, it is loading it in the proper classes, in the class structure of that new format. So that means if we again run that old program, if you still have it, probably you don't have it, but as an example here, we can still run the old program. You see the storage still contains that old reference. If we now update a value, for one of the items we update the node to add the value new node content, and we run that program, so it is changed using the new program. You'll see that it has updated that node, so that's doing perfectly. But what happened to the storage? Well, actually it's storing only that one instance, so the other instance is still in the old format, and that means that the old program can still read it and display that reference field. The old format also tries to find a reference field which is no longer there because it's not stored by that second version of our program, so that means it becomes NULL in this case, but it has that new node content, so you can perfectly mix and match versions within a storage by MicroStream. Probably you want to convert it at one go, and you no longer are interested in the old data and reading the old data at some point, maybe initially, but at some point you want to get rid of that old format. You can use, for instance, the eager storer. You can ask for an eager storer and store the entire root, but better is only store, in our case, the leads, because we only want to manipulate where there is some change. So this store and commit will then store everything in the new format. We rerun the conversion. That's done quite rather quickly here, of course, because we don't have that much data. The new program can still read all the information with the nodes, even the new node content as we change it. The old program also can read it because it's still the same class. It is missing a few properties like that reference, so that means it is null, but it can still check, for instance, with the name, because here again he automatically tries to find out what is new and what is the change of the name. So he, here in the old version, he converts the new structure with contact name to the old structure, which is using name. In this example, we show you how you can define those mappings in a manual, and you define the mappings yourself. It's not that the system tries to figure out the old property names and the new property names. And with this manual mapping, you can also change the class name. So again, we have, in this case, we have a contact. So we have an earlier version of our program where we still call it contact with a few properties, and we want to change it to a new class name which is called lead. This cannot done automatically. You need to help MicroStream to say what is old and what is new, and here we are not intervening with the matching between the properties, but that's also something you can do. So we run the old version of the program, and again it has some entries, and it is creating contacts. And in our new program, then we need to, of course, to configure it. So when we create the embedded storage foundation, we need to supply it a mapping provider. A refactoring mapping provider is the full name of is the class name here for the legacy type mapping. Here in this example, you specify it as a key value pair, so the old name is contact and the new name is the lead, fully qualified class names. You also can specify it for properties. For instance, you can specify class, hash tag, and then the old property name, and then you can put it the new class name with the new property name. This is actually the CSV format, so that is an alternative, that instead of using here the code to define the mappings, which is fine for one, but if you have many of them, if you have multiple of them, it's probably easier to use a CSV, and then you can just indicate the location of the CSV file, and again use the set refactoring mapping provider to provide the data to MicroStream. And when we read then the storage again with that mapping available, then it will convert the data from the contact to the lead class. And since we did not specify all the mappings, you see that he also involves the automatic mapping where he detects that there are some new fields like that quality and that country. And that's a good thing that I show you that, because if you see in the printout, we have for the quality and is 0, so that was one of the new fields. It's an integer, so the default is 0, and the country is NL. But for the country, we actually specified the default value here. Specified country is equals to the default country, and that's not applied, and that's not an error, because MicroStream, when it reads data from a storage like we have here, it does not use the normal classic construction which is used in Java with the constructor, which we don't have here, but the default argument structure, and it does not use the instantiation here, the default instantiations, because it's purely transferring the data to and from an external location. This avoids a lot of security issues, but of course it can be a little bit confusing, especially at first, that although you have here apparently a default value, this value actually is annual, so be aware of that issue. Again, this leads program is only converting it into memory, so our old program is still able to run, but again, you should convert it at one go and then use the new version, of course, of your data structure. If you have an even more complex refactoring, then a simple mapping will no longer be able to perform what you need. For instance, if you have that contact, but you want to convert that contact into another class, a lead, but at the same time also introduce an address and a country instance, so that your postal code and your city here of the contact is converted to an address instance which is linked to the lead, then that mapping will not able to do that anymore, and you need a type handler yourself. You need to write a type handler yourself, which is more complex because you need to handle the low-level structure, how data is stored in MicroStream in this storage. But I briefly touch it and I will point you where the complete example is. You have then to create a legacy type handler, so not a mapper anymore, but actually a handler which reads the data in a binary format and creates new instances out of it. You need to provide the fields of the class which can handle this handler. So you basically need to define the version of the class which can handle it. You need to also define where the data are. So the first entry is a pointer for the name. So the second data and an email starts then after some more bytes, and you see you need to specify this, but at the end you can get all the data from the old structure. You can create, you get here a lead instance already, but you can set the values as you like. You can even perform some conversions like I do here with the postal code, etc. And that means that you can actually convert data here in one structure to any kind of structure that you like, with new instances and even processing of that postal code where we have the country in it and as the first character, and that we can create a country object for that. So you see all the examples are in that MicroStream legacy type mapping repository. You have that complex directory here with that complex example, what I was talking about. And you also have in the README an explanation for the automatic and the manual example that I gave you, the specific things that you need to be aware and how it works, including here a bit on that complex refactoring. So as you have seen with the legacy type mapping, it can handle your class changes. There are simple changes handled most of the time automatically, or you can define it manually to overrule it. And for class renames and for the complex refactoring, you will need the legacy type handler. So not a mapping, just a simple mapping, but a handler yourself. Thank you for watching and enjoy using MicroStream. Bye.